Good afternoon. Today we will see some theory related to root locus and then afterwards we will see problems. Now root locus method. Now the title of the chapter itself indicates that it is one type of graph. Locus you are knowing locus. Locus means it is one type of graph. Therefore what is the syllabus? Significance of root locus, angle and magnitude conditions, breakaway points, angle of departure and angle of arrival, construction of root locus using general rules and steps. Therefore, first of all, we will see some theory and afterwards we will solve problem. Now, significance of root locus. The stability of any closed loop system depends on the locations of the roots of the characteristic equation. That is the location of closed loop poles. The nature of the transient response is closely related to the location of the poles in the S-plane. It is advantageous to know how the closed loop poles move in the S-plane if some parameters of the system are varied. Such movement of the poles can be known by root locus method, introduced by W.R. Evans in 1948. This is a graphical method in which movement of poles in the S-plane is sketched when a particular parameter of system is varied from 0 to infinity. In root locus method, gain is assumed to a parameter which is to be varied from 0 to infinity. In general, the characteristic equation of a closed loop system is given as now this is the closed loop system you are observing. RS is nothing but input, HS is nothing but feedback, CS is nothing but controlled output. Therefore, its characteristic equation is 1 plus GHHS is equal to 0. Why this plus sign is here? Because here negative feedback. If negative feedback is there, therefore here plus sign we have to give. Therefore, for root locus, the gain k is assumed to be a variable parameter and is part of forward path closed loop system. Consider the system shown in adjacent figure. Here GS is equal to K into G dash of S, where K is equal to gain of the amplifier in forward path or also system gain. The characteristic equation becomes 1 plus GHHS is equal to 0, that is 1 plus K into G dash of S into H of S is equal to 0, which contains K as a variable parameter. If now gain K is varied from minus infinity to plus infinity, then for each separate value of K, we get separate set of locations of the roots of the characteristic equation. If all such locations are joined, the resulting locus is called root locus. So root locus is defined as the locus of the closed loop poles obtained when the system gain k varied from minus infinity to plus infinity. When k is varied from 0 to infinity, the plot is called as direct root locus, while when k is varied from minus infinity to 0, the plot obtained is called as inverse root locus. But generally the term root locus is used in the sense of direct root locus. Unless otherwise stated, the variation in gain k is assumed to be 0 to plus infinity and plot is called root locus. For example, consider unity feedback system with g of s is equal to k divided by s to obtain its root locus. The characteristic equation for closed loop system is 1 plus GHHS is equal to 0, but for unity feedback system, HS is equal to 1. Therefore, G of S and G of S is equal to K divided by S given. Therefore, 1 plus K divided by S is equal to 0. Therefore, S plus K is equal to 0. Therefore, the root of this equation is located at S is equal to minus K. Now, if gain K is varied from 0 to plus infinity, the location of this root is going to be changed. So the locus obtained by joining all such locations when k is varied from 0 to plus infinity is root locus as shown in figure below. Therefore, always remember in case of root locus, x axis is known as real axis and y axis is known as imaginary axis. Y axis is known as imaginary axis, x axis is known as real axis. Therefore, towards right side positive values are there, towards left side negative values are there. Now angle condition and magnitude condition. What is meant by angle condition and magnitude condition? For a general closed loop system, the characteristic equation is 1 plus GHHS is equal to 0. Therefore, GSHS is equal to minus 1. As S plane is complex, we can write above equation as GHHS is equal to minus 1 plus J0. All S values can be expressed as sigma plus J omega, that is G of S into H of S term is also complex one. So, for any value of S, if it has to be on the root locus, it must satisfy the above equation. As both sides of above equations are in rectangular form, we can convert both sides in polar form and then we can equate angle and magnitudes of both sides. Now what is my angle condition? The characteristic equation as mentioned above is g of s into h of s is equal to minus 1 plus j0, equating angles of both sides. Therefore, angle of g of s into h of s is h of s is equal to plus minus into bracket 2q plus 1 into 180 degree, where q is equal to 0, 1, 2, 3, 4, dash 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 up to infinity. Minus 1 plus j0 is equal to 1 angle of plus minus 180, but the point minus 1 plus j0 is a point on negative real axis which can be traced as magnitude 1 at an angle plus minus 180 degree plus minus 540 degree plus minus 900 degree dot 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 plus minus 2q plus 1 into 180 degree. Therefore, angle condition can be stated as angle of g of s into h of s for any value of s which is the root of equation. Therefore, into bracket 1 plus g of s into h of s is equal to 0 is, which is equal to plus minus 2q plus 1 into 180 degree, where q is equal to 0, 1, 2, 3 dot dot dot, which is equal to odd multiple of 180 degree. Always remember, if we have to find out the angle, we have to use this condition, that is g of s into h of s is equal to plus minus 2q plus 1 into 180 degree. Now magnitude condition. If magnitudes of both sides of the equation g of s into h of s is equal to minus 1 are equated, then we get a magnitude condition. Therefore, mod of g of s into h of s is equal to mod of minus 1 plus j0 is equal to 1. Now, in the function g of s into h of s, k is unknown and hence we cannot find out mod of g of s into h of s at any point in S plane. So this condition is not suitable to check the existence of a point on the root locus. But once we know that a point in the S plane is on the root locus, then it must satisfy magnitude condition also. So at that point which is known to be on the root locus by angle condition, we can find out value of k by using magnitude condition. This k is value of gain for which a known point on root locus is the root of quadratic equation. So magnitude condition states that mod of g of s into h of s at a point in S plane which is on the root locus is equal to 1. So magnitude condition can be used only when a point in S plane is confirmed for its existence on the root locus by use of angle condition. Now breakaway point. It is a point on a root locus where multiple roots of characteristic equation occurs for a particular value of k. The root locus branches. Branch means leaves. Always remember. Branch means to start from that point or to leave that point. We are knowing in tree different branches are there. Now how that branches are formed? First of all, one small leaf is coming from the main trunk. Trunk म्हणजे खोड, or one branch is there, major branch. Small leaf is coming and then afterwards it grows and it becomes branch. Therefore, branch means the point where the root locus leaves or starts or comes out from the real axis or x axis. The root locus branches always leave breakaway points at an angle plus minus 180 upon n, where n is equal to number of branches approaching at breakaway point. As breakaway point indicates values of multiple root, it is always on the root locus. Angle of arrival and angle of departure. Angle of arrival and angle of departure are discussed below. As branch always leaves from an open loop pole, it is advantageous to know at which angle it departs from complex conjugate pole. This angle at which it departs from complex conjugate pole is called angle of departure, denoted as phi d, and vice versa. It is an angle of arrival denoted by phi a. Therefore, phi d is equal to 180 degree minus phi, where phi is equal to summation of phi p minus summation of phi z, where summation of phi p is equal to contributions by the angles made by remaining open loop poles at the pole at which phi d is to be calculated. Summation of phi z is equal to contributions by the angles made by the open loop zeros at the pole at which phi d is to be calculated. Now construction of root locus. Now these are, we will see some rules how to construct the root locus. Following rules are used while constructing a root locus. Rule number 1. The root locus is always symmetrical about real axis. Real axis means x axis. The roots of the characteristic equation are either real or complex conjugates or combination of both. Rule 2. Analyze basic information about the system, which will include A. Number of open loop poles, B. Number of open loop zeros, Z. Number of branches emerging or starting from open loop poles, and D. Number of branches terminating or ending at open loop poles. Now number of closed open loop poles, P. Let Cs upon Rs is equal to K divided by S into bracket S plus 1 into S plus 2. Therefore, number of S terms in the denominator, indicates number of poles, always remember. And number of S terms in the numerator indicates number of zeros. Therefore, in the example given, in the numerator 3 S terms are there. Therefore, S is equal to 0, S is equal to minus 1, and S is equal to minus 2. Therefore, 3 open loop poles are there. For calculating open loop zeros, now you see in this equation, K divided by S into bracket S plus 1 into S plus 2. Here, number of S terms in the numerator is 0. Therefore, number of zeros Z is equal to 0. Now consider this equation. Cs upon Rs is equal to K into bracket S plus 1 into S plus 2 divided by S plus 3. Therefore, number of S terms in the numerator is equal to 2. Therefore, number of zeros Z is equal to 2. And number of S terms in the denominator is equal to 1. Therefore, number of poles P is equal to 1. Number of branches terminating an open loop 0. For calculating number of open loop zeros of the given system, equate the numerator of the equation to 0 and evaluate the end points of the branches. There are 3 cases. Case 1, if number of zeros in the given equation is 0, then all the branches emerging from an open loop poles terminate at infinity. Therefore, Cs upon Rs is equal to K divided by S into bracket S plus 1 into S plus 2. Here, number of poles P is equal to 3 because number of S terms in the denominator is equal to 3. Z is equal to 0. Therefore, P minus Z is equal to 3 minus 0, which is equal to 3. Here, 3 branches starts with poles 0, minus 1, minus 2 and end at infinity. Case 2, if poles P is greater than 0 Z, therefore K into bracket S plus 1 divided by S into bracket S plus 2 into S plus 3. Here poles are 0, minus 2, minus 3 and zeros are minus 1, which is equal to 1. Therefore, P minus Z is equal to 3 minus 1 is equal to 2. Therefore, one branch will terminate at open loop 0 and two branches tends to infinity. Case 3, if poles P is equal to zeros Z, consider the equation Cs upon Rs is equal to K into bracket S plus 1 into S plus 2 divided by S into bracket S plus 3. Here P is equal to 2 and Z is equal to 2. Therefore, P minus Z is equal to 0. Therefore, no branches will terminate at infinity. Rule number 3, a point on the real axis lies on the root locus if the sum of number of open loop poles and the open loop zeros on the real axis to the right hand side of this point is odd. For example, g of s into h of s is equal to k into bracket s plus 1 into s plus 4 divided by s into bracket s plus 3 into s plus 5. Here p is equal to 3 and z is equal to 2. Therefore, p plus z is equal to 5. 3 plus 2 is equal to 5, which is equal to odd. Now, see here how to locate poles and zeros. Now here s is equal to 0, s is equal to minus 3 and s is equal to minus 5. Therefore, poles are there on the real axis. Poles and zeros are there on the real axis. Always remember. Therefore, s is equal to 0 minus 3 minus 5. 0 minus 3 minus 5. Poles are represented by cross and zeros are represented by circle. And s is equal to minus 1, s is equal to minus 4, s is equal to minus 1, s is minus 4. These circles are there. Now, how to identify where root locus region lies? 0 starts from this first pole 0. Now towards right side of the 0, how many poles and zeros are there? 0. Therefore, here no root locus region is there towards right side of 0. Now go to minus 1 point. At minus 1 point, how many poles and zeros are there? One pole is there. That therefore p is equal to 1 and z is equal to 0. Therefore, addition of p plus z is equal to 1. Therefore, since odd number of poles and zeros are existing towards right side of minus 1, therefore between minus 1 and 0 root locus will exist. Now go to minus 3 point. Towards right side of minus 3, how many poles and zeros are there? P is equal to 1 and z is equal to 1. Therefore, p plus z is equal to 2. It is even number. If it's even number, then between minus 3 and minus 1, there is no root locus region. Now go to minus 4. Towards right side of minus 4, what is the addition of pole plus 0? Pole plus zeros, 3 are there. 1, 2, 3. Therefore, between minus 4 and minus 3, root locus region exists. Now go to minus 5. Go to minus 5. Towards right side of minus 5. Towards right side of minus 5. If you will see, addition of poles and zeros is equal to 4. Therefore, even number. Therefore, between minus 4 and minus 5, no root locus region is there. And to the left side of minus 5 up to the minus infinity, root locus region exists. Therefore, this is the method to determine where root locus exists and where root now breakaway point. If the characteristic equation has multiple roots, the presence of breakaway point can be concluded as if two adjacent poles are connected together and region between them is root locus. In such cases, breakaway point exists. Two poles are there between two poles. If they are directly connected, therefore breakaway point will exist and root locus region lies between them. If two adjacent open loop zeros are connected together and region between them is root locus, in such cases, one breakaway point exists between them. Therefore, when two zeros are directly connected with each other and root locus region exists, therefore, their breakaway point will exist. If a open loop zero to the left of open loop zero, there is no poles or zero negative and region is root locus. So breakaway point lies in them. While solving problems you will understood it more clear. This is theory you will not understand, but while solving problem you will understand. Now rule number 4, angle of asymptote theta. The branches which are approaching to infinity do so along the straight lines called asymptote of the root locus. Asymptotes provide lines for the branches which approach to infinity. The angles of such asymptotes can be given as theta is equal to 2q plus 1 into 180 degree divided by p minus z, where q is equal to 0, 1, 2. Now consider how to find out angle of asymptotes, that is theta. Now consider this equation CS upon RS is equal to K divided by S into bracket S plus 1 into S plus 2. Here E is equal to and Z is equal to 0. Therefore substitute the value 2q plus 1 q q is equal to, you have to substitute 0, 1, 2, 3 dot dot dot. How many poles are there? P minus Z is equal to 3. Therefore you have to substitute 0, 1, 2 is in at q, and you will get theta 1 is equal to 360 degree, theta 2 is equal to 180 degree, and theta 3 is equal to 300 degree. Here q always starts with 0. Asymptotes are always symmetrically located about real axis. Real axis means x axis. Now centroid sigma. Asymptotes provides guidelines to the branches which are approaching to the infinity, but it cannot provide the location of asymptotes in S plane. All asymptotes intersect the real axis at a common point known as centroid, denoted by sigma. The coordinates are given as sigma is equal to summation of real parts of poles of G of S into H of S minus summation of real parts of zeros of G of S into H of S divided by P minus Z. Therefore, for example, C of S into R divided by R of S is equal to K divided by S into bracket S plus 1 into S plus 2. Here P is equal to 3, that is 0 minus 1 minus 2. Z is equal to 0. Therefore, sigma is equal to summation of 0 minus 1 minus 2 minus summation of 0 divided by 3 minus 0, which is equal to minus 3 divided by 3, which is equal to minus 1. Now real part is equal to, now see that how these angles are located. Now our centroid is 1 minus 1, therefore we have located minus 1, and from this point we have to draw the angle of asymptotes. Three angle of asymptotes are there: 60 degree, 180 degree, and 300 degree. Therefore always remember centroid is required to draw the angle of asymptotes. Now locating breakaway point. The location of breakaway point with the help of characteristic equation G of S into H of S is equal to K divided by S into bracket S plus 1 into S plus 2. The characteristic equation is 1 plus G of S into H of S is equal to 0. Therefore substitute G of S into H of S, this value here. Therefore 1 plus K divided by S into bracket S plus 1 into S plus 2 is equal to 0. Therefore S into bracket S plus 1 into S plus 2 plus K is equal to 0. Therefore S square plus S into S plus 2 plus K is equal to 0. Therefore S cube plus 2S square plus S square plus 2S plus K is equal to 0. Therefore S cube plus 3S square plus 2S plus K is equal to 0. Therefore K is equal to minus S cube minus 3S square minus 2S. Taking derivative with respect to S, therefore dk by ds is equal to minus 3S square minus 6x minus 2. Therefore S is equal to minus 0.42 and S is equal to minus 1.57. We get two breakaway points. These are the two breakaway points. We have to equate this equation to 0. This is the quadratic equation, and we have to find out roots of the quadratic equation. Now put the value of S in equation 1 and find out the value of K. If the value of K is positive, that breakaway point is valid for the root locus. The breakaway points for which values of K are negative are invalid for direct root locus, but are valid for inverse root locus. Always remember, breakaway point lies in the root locus region. Now intersection of root locus with imaginary axis. Imaginary axis means y axis. After calculating exact location of breakaway points, we have to find intersection of root locus with the imaginary axis, which will finalize the direction of the curve, which can be done as follows. Consider characteristic equation 1 plus g of s into h of s is equal to 0, which was obtained during calculation of breakaway points as in rule 5. Arrange the equation in the form of Routh's array. Rule 6. Intersection of root locus with imaginary axis. After calculating exact location of breakaway points, we have to find intersection of root locus with the imaginary axis, which will finalize the direction of the curve, which can be done as follows. First, consider characteristic equation 1 plus g of s into h of s is equal to 0, which was obtained during calculation of breakaway points as in rule 5. Arrange the equation in the form of Routh's array method to get marginal value of k. After calculating marginal value of k, use the auxiliary equation d of a or a of s is equal to 0. Roots of auxiliary equation a of s is equal to 0 for k is equal to k marginal are nothing but the intersection points of the root locus with imaginary axis. Therefore, g of s into h of s is equal to k divided by s into bracket s plus 1 into s plus 2. The characteristic equation is 1 plus g of s into h of s is equal to 0, which is therefore 1 plus k divided by s into bracket s plus 1 into s plus 2 is equal to 0. Therefore, s cube plus 3s square plus 2s plus k is equal to 0. Therefore, we have to arrange this equation in Routh's array. First of all, you have, towards left side, you have to write down s cube, s square, s raised to 0. Now, in front, नेट गेलं नाही नेट गेलं तरी आपलं हे चालू हे चालू राहते ना ओ मोरे सर नेट गेलं तरी आपलं हे चालू राहते ना म्हणजे मी जे हे करतो ते बोलू शकतो ना फक्त मुलांना दिसत नाही चालते की आपल्याला प्लीज वेट देर इज नेट प्रॉब्लेम इन कॉलेज प्लीज Okay. Now internet connectivity is there. We will start. Net resumed. Therefore, towards left side we have to write s cube, s square, s raised to 0. Now s cube in front of s cube you have to write coefficient of s cube first is 1. Then you have to jump to 2s, therefore 2. Now s square in front of s square you have to write 3, and then like this k. Now in front of s what you have to do? 3 into 2 minus k into 1 divided by 3. Therefore 6 minus k divided by 3. Similarly for s raised to 0 you have to write k into this 6 minus k divided by 3 minus 3 into 0 divided by 6 minus k in divided by 3. Therefore k value is there. Therefore for stability 6 minus k divided by 3 is greater than equal to 0. Therefore 6 minus k greater than equal to 0. Therefore 6 minus k is equal to 0. Therefore k is equal to 6. Therefore k marginal is equal to 6. Therefore k is equal to 6. Take auxiliary equation, that is k marginal is equal to 6. That makes row corresponding to s raised to 1 as row of zeros. Therefore 3s square plus 6s raised to 0 is equal to 0. We have to substitute value of k. Therefore 3s square plus 6 is equal to 0. Therefore 3s square is equal to minus 6. Therefore s square is equal to minus 2. Therefore s is equal to plus minus 1.414j. Now rule number 7, angle of departure and angle of arrival. Angle of departure at complex conjugate poles. For open loop poles, angle of departure is calculated if the pole or roots of the characteristic equation are complex. For complex root, which is equal to open loop pole, phi d is equal to 180 degree minus phi, where phi is equal to summation of phi p minus summation of phi z, where phi d is equal to angle of departure. Summation of phi p is equal to summation of angle at poles. Phi summation of phi z is equal to summation of angles at zeros. Now angle of arrival for an open loop 0. Angle of arrival is calculated if roots of characteristic equation is complex. For complex root is equal to open loop 0. Phi a is equal to 180 plus phi, where phi is equal to summation of phi p minus summation of phi z. Now rule number 8, plot root locus. By using all of our rules, plot root locus on the graph paper with proper scale. Rule number 9, comment about stability. From the root locus drawn in above step, comment on the stability of the system by calculating k marginal. Therefore this is the theory. Now we will see the how to solve the problem. Therefore this is the first problem. Please write down the problem. We will wait for 5 to 10 minutes. Please write down the problem. Please wait for 5 minutes. I will start lecture. Okay, we'll see now problem. First problem, draw the approximate root locus diagram for a closed loop system whose transfer function is given by g of s into h of s is equal to k divided by s into bracket s plus 5 into s plus 10. Here given transfer function is g of s into h of s is equal to k divided by s into bracket s plus 5 into s plus 10. Therefore, first of all, step 1, see the steps. Calculation of number of poles and number of zeros and number of branches. Therefore, here denominator of function is s into s plus 5 into s plus 10. Therefore, equating these three values to 0, we are getting s into bracket s plus 5 into s plus 10 is equal to 0, and therefore s is equal to 0, s is equal to minus 5, and s is equal to minus 10. Therefore, number of poles p is equal to 3, which is equal to s is equal to 0, s is equal to minus 5, and s is equal to minus 10. Also, the numerator is k only with no s terms. Therefore, number of zeros will be 0. That is z is equal to 0. As in the numerator there is no s term. Therefore, number of zeros z is equal to 0. Therefore, number of branches is equal to p minus z, which is equal to 3 minus 0 is equal to 3 branches. All are starting from 0, minus 5, minus 10, and ending at plus infinity, as there are no zeros. Now, step 2, we have to locate number of poles and number of zeros, and we have to find out root locus region and no root locus region. Therefore, as there is one poles to the right of pole, first of all you have to draw two axes. X axis is known as real axis and y axis is known as imaginary axis. Towards left side negative value, towards right side positive value. Therefore, you have to locate the points 0, minus 5, minus 10. Since they are poles, therefore indicated by cross. Now go to 0. Towards right side of the 0, number of poles and zeros are 0. Therefore, here no root locus region towards right side of 0. Now go to minus 5. Towards right side of minus 5, number of poles and zeros are 1. Therefore, between minus 5 and 0, root locus region exists. Go to minus 10. Towards right side of minus 10, number of poles and zeros are 2, which is even number. Therefore, between minus 10 and minus 5, no root locus region. And towards left side of minus 10 up to minus infinity, root locus region exists. Therefore, this is the location of root locus region and no root locus region. Step 2. Now step 3, angle of asymptote. Now how many branches are there? Number of branches n is equal to 3. Therefore we have theta is equal to 2q plus 1 into 180 degree divided by p minus z. Therefore for q is equal to 0, 1 and 2. Since number of branches n is equal to 3, therefore we have to take only first three values of q, that is 0, 1 and 2. Therefore substitute all the values here and we will get theta 1, theta 2 and theta 3. Therefore theta 1 is equal to 60 degree, theta 2 is equal to 180 degree, and theta 3 is equal to 300 degree. Please write down this. All of you please write down. Anyone is writing? Therefore three angles we have got, theta 1, theta 2 and theta 3. Now calculation of centroid. Step 4. Centroid sigma is equal to summation of real parts of poles minus summation of real parts of zeros divided by p minus z. Therefore sigma is equal to 0 minus 5 minus 10 minus 0 divided by 3 minus 0, which is equal to minus 5. Therefore locate centroid sigma at minus 5 and draw the angles from minus 5, that is 60 degree, 180 degree and 300 degree. Now step 5, breakaway point. The characteristic equation is 1 plus GHHS is equal to 0. Therefore 1 plus k divided by s into bracket s plus 5 into s plus 10 is equal to 0. Therefore s cube plus 15s square plus 50s plus k is equal to 0. Therefore k is equal to minus s cube minus 15s square minus 50s. Therefore dk by ds is equal to minus 3s square minus 30s minus 50 is equal to 0. Therefore minus 3s square minus 30s minus 50 is equal to 0, or 3s square plus 10s plus 16.67 is equal to 0. Therefore we have to find out roots of this quadratic equation. Therefore we are getting s is equal to minus 2.113 and minus 7.88. Now these two values, we have to select only one value which is lying in the root locus region only. Therefore this minus 2.113, this value lies in the root locus region. Therefore we will consider minus 2.113 as the breakaway point, because this minus 7.88, this lies in the no root locus region. Step 6, intersection with imaginary axis. We have our characteristic equation as s cube plus 15s plus 50s plus k is equal to 0. Therefore again this is Raoult's circle. Towards left side we write down s cube square s raised to 1 s raised to 0. Now this coefficient of s cube is 1. We have to take coefficient of s, then here you have to write, and coefficient of s square 15, and again you have to take this value k. Now you have to obtain s raised to 1 in front of value of s raised to 1. You have to obtain like this: 15 into 50 minus k into 1 divided by 15, and here it is 0. Similarly, at s raised to 0, value of k will come. Now row of s raised to 1, we have 750 minus k divided by 15 is equal to 0, or 750 minus k is equal to 0. Therefore k is equal to 750. As k is positive, it must intersect with imaginary axis. Again, the auxiliary equation is a of s is equal to 15s square plus k is equal to 0. Therefore 15s square plus 750 is equal to 0. Therefore s square is equal to minus 750 divided by 15, which is equal to minus 50. Therefore s is equal to plus minus g into root of t, which is equal, therefore s is equal to plus minus j into 7.071, intersection with imaginary axis. Now step 7, angle of departure. Therefore since no complex poles are there, hence calculation of angle of departure is not required. Root locus breaks at plus minus 90 degree at breakaway point. Now stability of system. For the range 0 less than 750 less than k, system is stable as the entire root locus lies in the left of S plane. At k is equal to 750, the system is marginally stable. For 750 less than k less than infinity, system is unstable as root locus now move in right side of S plane. Now how to draw the root locus? Just check. First of all, draw x axis and y axis. X axis is known as real axis, y axis is known as imaginary axis. Step 2, we have to find out root locus region and no root locus region. You have to draw, indicate the poles 0, -5, -10. Therefore, poles are indicated by cross. Therefore, this cross is there. Now, towards right side of 0, 0 number of poles and zeros are there. Therefore, between 0 and towards right side, no root locus region. Now, -5 towards right side of -5. Addition of poles and zeros is equal to 1. Therefore, it is odd number. Therefore, since odd number is there, therefore between -5 and 0, root locus region exists. Now -10 towards right side of -10. Number of poles and zeros are equal to 2. Therefore, between -10 and -5, no root locus region. And -10 to minus infinity, again root locus region exists. Now location of centroid. We have calculated value of centroid sigma is equal to -5. Therefore, locate sigma centroid -5. Now step 4, drawing of angle of asymptote. Now we have calculated three angles, 60 degree, 180 degree and 300 degree. Therefore, locate the angles at -5, that is 60 degree, 180 degree and 300 degree. Now location of breakaway point, step 5, locate breakaway point, that is -2.11. Now intersection with imaginary axis, we have calculated these values. Intersection with imaginary axis, S is equal to plus minus J 7.071. Therefore, you have to indicate this value on y axis, means like this, plus sorry, plus J 7.07 and minus J 7.07. And now you have to draw the root locus. How to draw? Just check. Always remember, root locus start from open loop pole. Root locus start from open loop pole. Now why these angle of asymptotes are there? Because root locus is symmetric or parallel to the angle of asymptote. Therefore, root locus first of all will start from 0. It will go to -5. While going to -5 up to -5, it will branch from this breakaway point. Therefore, and it will intersect with imaginary axis at plus 7.07 J and minus 7.07 J. And again, root locus will start from -10 to minus infinity. Therefore, this is your root locus. This is the your root locus. Therefore, this is the first problem. Now we will see second problem. Please write down the problem. I will wait. Okay, this is our second problem. G of s into h of s is equal to k divided by s into bracket s square plus 2s plus 2. Sketch the root locus for the system. Therefore, we will write down this equation again. Solution g of s into h of s is equal to k divided by s into bracket s square plus 2s plus 2. Now step 1, calculation of number of poles, number of zeros and number of branches. Here denominator of the given function is s into bracket s square plus 2s plus 2. Equating it to 0 will give poles, that is s into bracket s square plus 2s plus 2 is equal to 0. Therefore s is equal to 0, or s square plus 2s plus 2 is equal to 0. Therefore s is equal to 0. And by solving this quadratic equation we are getting another two roots, that is s is equal to minus 1 plus minus j. Therefore number of poles p is equal to 0, minus 1 plus j, and minus 1 minus j. Therefore, p is equal to 3. Now, since there is no s term in the numerator, so number of zeros z is equal to 0. Therefore, z is equal to 0. Therefore, number of branches is equal to p minus z, which is equal to 3 minus 0 is equal to 3, terminating at infinity. Therefore, we will locate step 2. We will locate this pole 0 plot and we will find out root locus region and no root locus region. Therefore, first pole is 0. Therefore, indicate cross here. Second pole is minus 1 plus j, minus 1, and this plus j. First, second cross, and minus 1 minus j. Again, therefore, this much is there. Therefore, towards right side of 0, no root locus region, and towards right side of this plus minus, minus 1 plus minus j, root locus region exists. And again, towards left side of minus 1 plus minus, minus 1 plus minus j, up to minus infinity, root locus region will exist. X axis is known as real axis, y axis is known as imaginary axis. Now, angle of asymptote. Now, since p minus z, number of branches, n is equal to 3, therefore we have to take first three values of q, that is 0, 1, 2, and consider this equation. Theta 1 is equal to 2q plus 1 into 180 degree divided by p minus z. Therefore, substitute values of q, 0, 1, and 2. Therefore, theta 1 is equal to 60 degree, theta 2 180 degree, theta 3 300 degree. Now we will calculate first of all centroid and then we will draw the angles. Now centroid sigma is equal to summation of real parts of poles minus summation of real parts of zeros divided by p minus z. Therefore, sigma is equal to 0 minus 1 minus 0 divided by 3, which is equal to minus 2 divided by 3, which is equal to minus 0.67. Therefore, locate this point minus 0.67 and from this point draw the angles 60 degree, 180 degree, and 300 degree. Now we have to calculate breakaway point. Therefore, breakaway point is given by the characteristic equation 1 plus GHHS is equal to 0. Therefore, 1 plus K divided by S into bracket S square plus 2S plus 2 is equal to 0. Therefore, S into bracket S square plus 2S plus 2 plus K is equal to 0. Therefore, K is equal to minus S cube minus 2S square minus 2S is equal to 0. We will take S common. Therefore, dk by ds is equal to, sorry, we have to differentiate it. Dk by ds is equal to minus 3s square minus 4s minus 2. Therefore, minus 3 plus 3s square plus 4s plus 2 is equal to 0. Solve this quadratic equation. Therefore, s is equal to, we are getting minus 0.66 plus minus 0.471 j. Therefore, as roots are complex, no breakaway point is there. If always remember, if roots are complex, this root is complex, minus 0.66 plus 0.471 j and minus 0.66 minus 0.471 j. Therefore, no breakaway point is there. Now, intersection with imaginary axis. The characteristic equation is s cube plus 2s square plus 2s plus k is equal to 0. Therefore, by Raoult's array method, s cube, s square, s raised to 1, s raised to 0. Again, in front of s cube, we have to write 1 and coefficient of s, that is 2. In front of s square, we have to write coefficient of s square and this k, 2k. And how to obtain here value? 2 into 2 minus k into 1 divided by 2, 0. And s raised to 0, k. Therefore, 4 minus k divided by 2 is equal to 0. We have to equate it. 4 minus k divided by 2 is equal to 0. Therefore, k is equal to 4. As k is positive, it will intersect to imaginary axis. Therefore, k is equal to 4. We have 2s square plus k s raised to 0 is equal to 0. Therefore, 2s square plus 4 is equal to 0. Therefore, s square is equal to minus 2. Therefore, s is equal to minus plus minus 1.414 j. So root locus will intersect at plus 1.414j and minus 1.414j. Now angle of departure. Angle of departure. Now as our poles are complex poles, that is minus 1 plus j and minus 1 minus j, we have to calculate angle of departure at minus 1 plus j and minus 1 minus j. Therefore, join all poles to minus 1 plus j. Therefore, join all these poles. Now, angle at pole 0 is equal to 5p1 is equal to 180 minus x. What is the value of x? This triangle we have to consider, right angle triangle. Tan inverse of 1 divided by 1, therefore 180 degree minus 45 is equal to 135. This is 135 degree angle, 5p1. Now 5p2, this is 5p2 angle, 90 degree. Therefore summation of 5p is equal to 5p1 plus 5p2 means 135 plus 90 is equal to 225. And summation of phi z is equal to 0 as no 0 is there. Therefore phi is equal to summation of phi p minus summation of phi z, which is equal to 225 minus 0, which is equal to 225 degree. Therefore angle of departure is at minus 1 plus j. Therefore phi d is equal to 180 degree minus phi, which is equal to 180 degree minus 225. Therefore phi d is equal to minus 45 degree at minus 1 plus j, and at minus 1 minus j it is plus 45 degree. Now this is your root locus. X axis is known as real axis, y axis is known as imaginary axis. Therefore locate the poles 0, minus 1 plus j, minus 1 minus j. Centroid you have to locate minus 0.67. Draw the angles theta 1, theta 2 and theta 3. Now you have to construct the root locus. Now for root locus always start from open loop pole, always remember. Therefore since three angles are there, three angle of asymptotes, therefore number of branches p is minus z, n is equal to 3 will be there. Therefore this is the first branch, 0 to minus infinity. This horizontal line is the first branch. Now this is the second branch. Now here minus 45 degree angle is there, therefore you have to draw minus 45 and you have to draw it tangentially, and it will intersect at minus plus 1.414j. Therefore you have to intersect it and you have to draw parallel to this 60 degree. Similarly at the bottom it is plus 45 degree. Therefore you have to draw a line parallel to a 300, and value is minus 1.414j. Therefore this is nothing but your root locus, three branches. First branch is 0 to minus infinity, horizontal line towards left side. This is the second branch and this is the third branch. Okay, we will stop here, and in next practical again I will take two problems, two to three problems, and then this chapter will over. Enter, please enter your numbers. Thank you very much.